So today we're going to introduce you to a simple drivetrain project. So drivetrains are pretty cool in VEX. They go beyond just allowing you to have your motors move and add the capability to sort of control with precision how far you turn, how far you go forward and backward, and let's take a look at this. So first of all, I have my little setup here, and this is just a heads up for you guys. You don't have to have a full robot working to experiment with VEX code. I just have one, I think it's a 5x25 piece of C channel, and then I have the motors connected through here so we can see if it's going to work. So anyway, you're going to say File, Make a New Project. And I don't care what you call it. This is going to be a drivetrain experiment, so that's maybe a good idea for a name. Let's go up here. And the first thing that they're going to want you to do is click on this button. It's the third from the right, and it brings up Add a Device. So I'm going to click on Add a Device. And you may be familiar with, you can add the controller and motors and all the different sensors, but they have these pre-created drivetrains for 4 motors and 2 motors, and we're going to take a look at that. So when I selected a 2-motor drivetrain, first it says select left motor, select a port, and the default is port 1 for the left motor. Doesn't really matter. You can pick any port you want, just so that you remember that on your physical robot, if you said it was going to go into port 1, then you better, if you said it was going to go into port 1 in your code here, then you need to make sure on your physical robot you connect the wire, the cable, into port 1. And so they're telling me that the default for the right motor is 10. Once again, just make sure that how you configured it here is the same as how you connected it on your physical robot. Now here's the interesting stuff. We need to click on drivetrain right here. And you may have different sized wheels. The programming accounts for all of this and will control your distances based on it. So you literally make sure you have 4-inch wheels. If not, you might change them to maybe you have 5-inch wheels, maybe you have 6-inch wheels, but you would change your wheel size to correspond to whatever wheels you have on your robot. Track width is the distance from the outside of one wheel to the outside of the other wheel. And this is based on what's called the Clawbot, which is something that they have instructions for. But if you have a longer track width, then you're going to need to change this accordingly for all the programming to work the way it's supposed to. It will just not be precise if you don't have this done accurately. Wheelbase is the distance from the center of the front wheel to the center of the back wheel. So let's do that one more time. Track width is how far from the outside of one wheel to the outside of the other wheel. Wheelbase is the distance from the center of the front wheel to the center of the back wheel. You can change your gear ratios if you don't have this cartridge. I don't think are dealing with that right now. I'm just going to say done. So now I've selected that drivetrain. You're going to need to do this first before you add the next code that I'm going to enter, because it just won't even recognize it. If you don't have a drivetrain selected with motors, then this code is not recognized. But if you did have that entered, then you're going to, down in the code, we're going to say D. And notice it's already self-populating drivetrain, so I can hit enter. I don't have to type that out. Dot, and then it's giving me all these choices. We're going to do drive 4, and when I select drive 4, it's going to have 3 parameters: direction, distance, units. Direction, distance, units. So let's go ahead and select drive 4, and it opens up parentheses for me. We'll select forward. That's our direction. Distance, it could be 20, 40, 50, 100. Let's try 35. And units. it said inches, but I believe if I said M, it could give me millimeters. So obviously that's going to be a lot shorter. Let's do that to save some energy. I'm going to close my parentheses, and don't forget your semicolon. And that's the whole program. And let me see here. I just want to make sure that that you're able to see this. Okay. Here's my camera, which shows my my assembly over here. I'm going to download the program. I'm going to hit run once it loads up. And when I hit run here, you see what happens over here. Oh, that was quick, huh? 35 millimeters, not very far. So let's real quickly try going back to our program. Minimize that. Let's change millimeters to inches. Inches. Download that. And now run it. A little bit better. Okay, there you go. That's the drivetrain selection. That's configuring a 2-motor drivetrain in VEX.